Thanks, everybody. As humans, we naturally gravitate towards focusing on negative news. This is part of human nature, and it's likely because of evolutionary reasons, meaning that our ancestors, the ones that were more consuming more good news, likely those didn't make it. Jokes aside, the challenge we have is that we often adopt a more pessimistic outlook about the world. But if we focus on the metrics, because sometimes because of this, it's difficult to see how much progress we have made as a society. But if we focus on the metrics, areas like infant mortality rate, or people living in extreme poverty, or global literacy rate, all of these metrics have been improving decade after decade after decade. And a lot of these improvements are driven in large part by technology. From electricity to vaccines to communication, technology has played a fundamental role in advances in society. And within technology, there is a subset of technological advances that have significant effect. These are the technologies that can impact an entire economy and have the potential to drastically alter society through their impact. Economists call this GPT. And if you're here today, you're likely thinking of a different GPT. This is not the one that you're thinking. This is general purpose technology. General purpose technologies are technologies that have a profound impact on the way we live and work and have moved the human race forward. Since the beginning of civilization, economists have identified there has been 25 general purpose technologies. A few examples include the wheel, the printing press, the electricity, trains, the PC, the internet. All of these technologies have fundamentally changed the way we live and the way we work. Today, I'm going to explain because AI is the next GPT. AI is a general purpose technology and has the ability to change the way we live and to change the way we work and move the human race forward. And I learned this in my past 5 years working directing our Microsoft AI for Good lab, where we work with organizations around the world using AI to help solve some of the world's greatest challenges. Some of these challenges include basic problems like identifying and understanding where do people live. And if you live in the US or if you live in Europe, we have this illusion that we know where everybody lives. Because if you go online and you search in a map, you will find your house. That data is up to date. But if in areas like Sub-Saharan Africa, this is certainly not the case. This is a picture of Cinder in Niger. This is from 2012. This is the last time they had a census, and majority of the maps they have are from this time. This is a picture, a more recent picture, also satellite picture of Cinder. Every blue dot that you have here in the screen is a house or human structure that is not in any map. If we don't know where people live, we cannot provide services to them. We cannot be better prepared from a disaster preparedness. We cannot help them in an event of a natural disaster. In 12 years, the city of Zinder moved from 300,000 people to 600,000 people, double the size. Half of the city is not in any map. And we learned this also in Afghanistan in the last earthquake. When the earthquake happened, majority of the people that were affected by the earthquake were not in any map. In a disaster response operation, if you don't know where do people live, there's no way that you can help them. So for the past 2 years, we've been working in collaboration with Planet and the Institute of Health Metrics in the University of Washington to create an up-to-date map of the population density across the entire world. This information is critical from a disaster preparedness point of view. If we know where people live, then we can interlace this data with climate data, food insecurity, disease burden, combining all this information together, providing a very good understanding or where do countries should focus to make sure that we understand where are the risks from a disaster preparedness. In the event of a natural disaster, this information is also critical. This is Libya, the day before the flooding. This is after the flooding. We use AI models to detect every single thing that changed between before and after. And after we identify the before and after, we can identify every single structure that was affected. All of these maps are provided to teams on the ground. If we do a good job and we get this information between 24 to 48 hours, this information to people on the ground is critical to understand where, how much resources they need to deploy and to where. This information can help the teams on the ground help save lives. This is some of the other floodings that happened early this month, both in Brazil and in Kenya. Similar work, using high-resolution satellite data, using AI on top of high-resolution satellite data, we can map every single structure that was affected by these disasters. And we're using something similar also in the Amazon to detect illegal deforestation. We have daily data from these satellites. Using AI models, we can run these detections and we can map early signs of deforestation. This information can provided to teams on the ground, can also help them make sure that the right authorities can affect the outcome of this deforestation. On a different note, we also work on healthcare, areas like pancreatic cancer. Pancreatic cancer has the highest mortality rate of all cancers. And if you see here in the screen, for majority of the other cancers, the probability of dying within 5 years have improved over time. But in the case of pancreatic cancer, it has been relatively small. And the reason this happens is because when we detect pancreatic cancer, it's usually too late. So we're working with doctors at the Johns Hopkins University to see, using AI on top of CT scans, we can help them detect when pancreatic cancer is less than 2 centimeters large. Because if we can detect pancreatic cancer when it's lower than 2 centimeters, you can do a surgery and you can help save that life. A year and a half ago, with the release of GPT, the world changed for everybody. But more important, changed for us, for people that were using AI to help solve some of these problems. As with any technology, we need to understand the power, but we also need to understand the limitations that these models have. Today, I'm going to be covering 8 different insights about this technology. The first one, and very important to understand, is no matter how sophisticated these AI models appear to be, behind the scenes, these models are just math. These models do not possess any real cognitive abilities. They are simply performing a lot of mathematical and linear algebraical calculations. The only reason they appear to behave like humans is because they are trained in human data. If Excel allowed very big formulas, and when I say very big, are huge, large formulas, that doesn't. But let's say for a minute that we didn't have that limitation. You could literally technically encode a whole LLM in using Excel formulas. LLMs do not have reasoning or intentionality. Their outputs are driven by statistical correlations, not by deliberate thoughts or reasoning. The only thing an LLM is doing is try to predict the next word. Given a phrase, what is the next word? So for example, if I ask you, this morning I woke up and saw a beautiful blue, what is the next word? You likely say sky. This is what an LLM is doing. It's giving a context, trying to predict what is the next word. And learning that distribution. That sky is not the only option. It could be blue car, blue bird, but it will have lower probabilities. It's learning that probability distribution. Once you infer what is the next word, because of the generative aspect, you can do it again and again and again. And you're basically running this through the whole answer. LLMs do not know what is true. The corpus, the data that we use to train will indicate what is true and what is not true. This is why it's critical to make sure that we point these LLM training datasets to the right datasets, because they will learn from the data that we have. LLMs, as likely a lot of people that have used them, can hallucinate. And the reason they can hallucinate is because they are learning this probability distribution. They don't know. They just inferring data from that probability distribution. They don't know that they're hallucinating, because otherwise it would be relatively easy to solve the problem. That doesn't mean that we cannot help with that problem. There are ways that a lot of researchers are working on top of the LLMs to make sure to reduce the hallucination. But the reason the hallucination happens is because of the way these models are built. Generative models can be affected by bias. As a society, we suffer from bias. A lot of the content we produce and store in the web has some biases. And a researcher, Dr. Sasha Lucioni, did an amazing work where she showed for these generative models, the ones that generate images, that the distribution by gender was very skewed. Why? Because they were learning from a distribution that was already skewed. And this was also done in Bloomberg News by Leonardo Nicoletti and Dina Vaz, where they took the typical professions and asked these models to generate images. What they found was, in cases like engineer, majority of the results were mainly males. Where if you ask these models to generate images of social workers, majority of the images were females. We are learning from a biased data set. The models are learning. The problem is not the model. The problem is the data that we have. This doesn't mean that we cannot do anything to remediate this problem. We need to measure, we need to detect, and we need to invest in making sure that the data and the models do not suffer from these biases. This is a very difficult problem, by the way. But this is one of the problems that we need to solve. Even with all these problems, LLMs can be very powerful. The World Wide Web is our most important data set in the world. This is where we store. Majority of human knowledge is stored in these data sets. It would take 1 million years for a human to read all the content we have in the web. And until the LLMs, until recently, we could search the data, we could retrieve the data from search engines, but we couldn't convert this data into knowledge. The power that we have for the first time with large language models is our ability to treat this data set as an actual data set, to convert this data into knowledge. This is extremely powerful. The power that we have in LLMs is because by training on this very large data set, and basically when I say we're training, we're still training to learn the next word. But by training in this very large corpus, the model is forced to learn a representation of the world. And this is the one that provides the amazing powers that it has. And we have seen the amazing powers. GPT-4 has passed the bar exam, the US medical licensing, the radiology board exams, the MBA exams. These models are extremely powerful. And now we have the integration of multimodality. That is basically not just inputting text, but also images. This, by the way, is what we call a toy data set that is used to help people understand computer vision. This problem is called Chihuahuas versus blueberry muffins. And humans are pretty good detecting which one is a blueberry and which one is a dog. But if you're going to solve this from computer vision perspective, you need to create a training data set, you need to label data, you need to actually do a lot of manipulation of the data. It takes time. And it's not that easy. GPT-4o can solve this problem without a training data set. This is what is called zero-shot learning. You can, and this is extremely important. Why? Majority of the problems that we have fail because of access to data. Either we don't have the data to solve the problem, or there's no label data to solve the problem. With this type of multimodality, with the fact that we have large language models now with multimodal, and we can treat images in a zero-shot learning space, we can, for the first time, we can solve problems without a training data set. This opens many more scenarios than the ones that we thought we could solve. We are using this in our bioacoustic analysis. So we train AI models to detect different types of animals using AI. And this requires a huge amount of effort and a huge amount of expertise. You need experts that understand frequencies to be able to go and label specific animals on this data set. This takes a huge amount of effort. But now we are integrating into these models, and for the first time, we are able to ask the model in natural language, show me all the possible bird calls, and then have a human in the loop to basically identify them. This can significantly reduce the work of these scientists and make them much more productive. You can also solve problems like this, where you have a picture and you ask the model to understand whether you can park or not. Even for humans, by the way, this is a difficult problem. From an accessibility perspective, this provides an amazing power. There's no training data. This is zero shot. You go and you're asking GPT to solve that problem for you, inputting the image, and you get a result. There are still problems that you cannot solve using these models. For example, GPT-4o is pretty bad finding Wally or Waldo. It will give you a result, but many times it doesn't make any sense. So it has limitations, but still very powerful. LLMs can significantly improve productivity. There's a randomized controlled trials of using GitHub Copilot. GitHub Copilot is an LLM trained on coding to help software developers write code. It's a randomized controlled trial where you have a group of people that actually have GitHub Copilot and a group of developers that didn't have it. Those that have it were able to finish the task 55% faster than the control group. Not only that, there was quality improvements as judged by humans on 8 dimensions, including readability, error-free, and maintainability. And software development is not the only place where we see improvements in productivity. Boston Consulting Group did a randomized control trial where they took their consultants and asked them to finish tasks with and without GPT. The group that had GPT completed the task 12% more tasks, 25% faster, 40% higher quality. These are significant improvements in productivity. Why this is more critical than ever? Because for the first time in the history of humanity, the working age population of developed countries is actually going down. And more important, the ratio between the working age population and the rest of the population is also decreasing. This will put significant pressure in the global productivity. It will affect areas like healthcare, social security. So more than ever, we need to make sure that we become more productive, and AI can play a fundamental role in that area. Last but not least, generative models can help close the digital divide. LLMs have the power to make anybody an AI power user. You can go today to GPT, and like we saw in the example of the vision problems, and solve problems that before it would require not just a computer science degree, but also a lot of knowledge in machine learning to solve them. And a lot of time, a lot of hours and hours of coding. Now anybody can use their own natural language to solve these problems. It can help bridge the gap for people that have disabilities. You have 1.3 billion people in this planet that live with a severe disability. It can help on language translation. You have 40% of the global population does not have access to education in a language they speak or understand. And it certainly can help with coding. You have 7.95 billion. 99.95% of the population does not know how to code. Now, for the first time, we can use our own natural language to coding. Let me show you an example of this. This is a collaboration that we did with Planet Labs. Planet has an amazing data set of satellite data, but on top of that, they actually have a data set about things that they can learn from this satellite data. What we did was an interface where you could ask a question in English. A large language model will convert this question in English into Python code, execute that code, and get the answers. What you see here is actual questions and actual answers. Before something like this, you not only needed a Python developer, you need a Python developer that had good access to knowledge of geospatial data. Let me tell you one thing, it's not trivial to find those resources. Now, we have the ability to ask the question in English, the large language model is converting that question in actual Python code, executing the code, getting the answers. Extremely powerful. Large language models can provide an amazing power on education. There's a lot of disparities in education around the world. In developed countries, in elementary school, you will see a ratio between 1 to 12 to 1 to 20 students per teacher. In a lot of countries, the ratio can go to 1 to 50, 1 to 100. Once a week, I teach computer science at elementary school. And I have 12 students. And I can tell you that even with 12 students, it's very difficult for me to make sure that these students are learning. I cannot imagine how difficult it is to have to teach 50 students or 100 students. I think it's impossible. These large language models, like Sal Khan from the Khan Academy said, we can provide AI tutors to help these students make sure that they can ask questions and get the answers, and also at the same time making sure that the teachers can cut on the administrative tasks so they can create more time for the student-teacher interaction. 285 million people in the world are visually impaired. Now, thanks to technologies like the app that is called Be My Eyes, that is powered by a GPT vision model, these people can navigate the world with a phone and getting a description of what they are seeing. Jesse Lawrence, who is an accessibility specialist, said, as someone born blind, when I think back, I will remember it as the year when AI vision got real. And in her post, she said something even more interesting to me. One of my favorite aspects of the new world of AI vision is how it evokes emotions in me. I've literally gone through and relabeled all my favorite pictures of my kid on my phone because of the level of nuance it communicates to me about her face in each one. This is a mom for the first time seeing the emotions of her daughter in a description. AI is a new general purpose technology and provides amazing power to change the world. Together we can build a future of AI that benefits everybody. Thank you very much.